Okay. So finally, I suppose maybe I'll talk a little bit about why you're even in this class. Because, so I mentioned I just finished teaching Math 20B, which is for scientists and engineers. This class is not for scientists and engineers, which means there's a good chance that you may not use this material, right? We're going to be learning how to calculate integrals in this class. You may never calculate another integral for the rest of your life. So why should you care about it, right? Why should you be interested in and excited about this class? Here's a few reasons. Reason number one is a very tangible reason, and that is employers love it. This might be the hardest class that you take at UCSD, and if you can do well in it, then employers will think very highly of you. Even if you're not actually calculating integrals, arguably, I'm not really teaching you how to calculate integrals. I'm teaching you how to think critically and analyze. So in this class, you're going to be given, say, some theorems and some set of formulas, and it's going to be up to you to figure out how to apply those in a novel variety of circumstances. So in a way, it's kind of a test in your ability to think logically, which can help you in every aspect of your life. It will help you to basically to succeed at whatever it is that you want to do. Well, this class, one of the goals, arguably the most important, is to empower you with the ability to do that. So don't get bogged down thinking that like, oh, we're just learning integrals. No, no, no. We're learning how to think in this class. Now, another pretty cool reason that you should care about this, it's certainly the reason I care about it, is because math is the language of reality. So I wrote down a few of the most important discoveries in physics in the past few hundred years. One of them is classical mechanics. Classical mechanics is, well, it was basically invented by the same person that invented calculus. That was Isaac Newton, about 300 years ago. He was trying to describe gravity. But since then, there have been a number of other discoveries like Maxwell's laws of electricity and magnetism, and optics, and relativity, and quantum mechanics, all of which are described using mathematics. In fact, that math is the only way to describe them. So if you want to understand reality, you have to understand math. Moreover, there are lots of real-world problems that you can solve with mathematics. So, for example, let me show you the final exam that I gave in Math 20B last quarter. The first problem on it was about the SpaceX Starship. This is Elon Musk's spaceship that he wants to send to Mars, and he did a recent test flight with it. And the problem was about computing the height and speed and velocity, so forth, of this spaceship for the duration of the test flight. Or another final exam problem I gave involves finding the volume of a football for the NFL fans in here. Go Steelers. So those are a few examples of applications of mathematics, and I'm going to show you some more as we progress through the class. A third reason that I think you should be excited about this class is that math's beautiful. So as a couple of examples of the beauty of mathematics, I thought I would point out two that came up in the 20B class that I just finished teaching. One of them was fractals. So here are some images of fractals. Fractals are infinitely self-similar, meaning if you zoom in on a fractal, the more you zoom in, the more times you see the same shape repeated over and over again onto infinity. And these arise out of the study of complex numbers. They're actually not that hard to derive. Maybe a couple classes past this one, but they're beautiful. And they exist independent of human beings, okay? There's an argument about whether math is created or discovered. And I hope to convince some of you that it always existed and we just discovered it. And some of these beautiful pictures will hopefully go some way towards convincing you of that. And as another example of the beauty of mathematics, here's some polar art that my students in 20B did using equations that they plugged into polar coordinates, which we learned in that class, and were able to come up with these really pretty designs. Another reason that math is cool is that if we, as a species, ever make contact with aliens, math is likely to be our common language. And finally, it's part of a well-rounded liberal arts education. The whole theory of a liberal arts education is it's about learning topics which you might not specifically use in your life, but it's been found that a society is a better, more cohesive society when there's this group of common facts that everyone can agree upon and discuss. It allows you to connect with people. It allows you to speak the same language as other people. There's going to come a day after this class when there's a boy or a girl that you're trying to impress, and when you're able to talk about the language of mathematics and calculate some integrals, it'll be impressive. It'll look good for you. It'll help you to connect with people. It's in a similar way to how when my mother used to take me to Shakespeare plays when I was young. And I can quote lines from those Shakespeare plays. For the rest of my life, I am now a better person for what I learned there. And I'm hoping to sort of make some of those same changes in you. So